Today we're going to talk about day number 3, which is solving linear systems by substitution. So previously we've talked about solving linear systems by graphing. Now we're going to look at another method that is called by substitution. We are going to walk through some steps that are going to set up the process that we'll go about solving this, and then we'll work through some problems and apply that. So what does it mean to solve a system of two linear equations using the substitution method? Well, it means that we are going to be using this idea of substituting one value in for a variable or one equation into another equation for that variable to help us set up an equation we can solve. So step number 1, it says solve one equation for one of its variables. This is probably the most important step, because what we'd like to do is either get to the point where we can write it as y equals or possibly x equals. If we're allowed to isolate one of the variables, we can do this. It says we are going to look for cases where the coefficient or the multiplier in front of those variables is either a 1y or a 1x or possibly a negative 1. Once we have that done, step number 2 here says we would like to substitute that expression from step 1 into the other equation. Once you get that substitute in, you're going to have one equation that has one variable in it. So that is what allows us then to solve for one of the variables. Once you get that answer for, let's say we solved and we found x to be 2, once we get that answer of x is equal to 2, we're going to then substitute that value we just got in step 2 into the one of the equations at the top, one of the originals, that contains both variables, and solve for the other variable. The very last thing it reminds us is that we are going to be able to check our solution by plugging or testing into both of the equations. That ordered pair we just found, which is representing both x, comma y. So I'm going to take a look here at problem number 1 and notice that this bottom equation is already written as y equals. So step 1 said solve one equation for one of its variable. We have done that here. The next thing is I'm going to take and substitute y is equal to here and plug that into the top equation for y and rewrite this. So I get 3x plus, here is where I'm going to substitute in. What I'm going to substitute in here is in place of this y, I'm going to put in a 2x minus 10. And then that's equal to, at the top there, that was 5. So remember, this was 3x plus y equals 5. Well, all I did was, instead of calling this y, I took this and plugged it in here for y. From here, a lot of review from chapter 3, which was solving linear equations. Combine some light terms here. 3x and 2x is 5x. Minus 10 equals 5. Add 10 to both sides. 5x equals 15. So x is equal to 3. Once I have what x is equal to, now we're getting down here to step 3. Step 3 says take that value you got and substitute into one of the original equations. I'm going to substitute into the bottom equation. When I substitute into the bottom equation, I get y is equal to 2 times, I'm going to take this 3 and plug it in here for this x. So I'm going to originally write this as y equals 2x minus 10. But here's where I'm going to take this value of 3 and we're plugging it in right there. 4x. So it's 2 times 3 minus 10, which is 6 minus 10. So y is equal to negative 4, which, as I take a look here, my solution to this then is the ordered pair x comma y, where x was 3 and y is negative 4. Let's get ready to look at problem number 2. In problem number 2, I take a look, and I have one equation that needs to be written as either x equals or y equals. Well, I notice that the top equation can easily be written as x equals if I subtract over the 3y. If I subtract over the 3y, then I'm going to get x is equal to negative 3y plus 5. What that now allows me to do is to take and plug into the bottom equation what x is equal to. So that is what I'm going to get ready to show you here. So here we're going to substitute this in for x. So as I rewrite this, this is negative 2 times, instead of calling this x, what I'm going to plug in here is what I just told you x was equal to, which is negative 3y plus 5. Plus, we still have a y, equals a negative 3. I'm going to distribute, and I get 6y plus negative 10 plus y is equal to negative 3. As I combine like terms here, 6y and 1y is 7y, minus 10 equals negative 3. Add 10 over, and I get 7y is equal to 7, divide by 7, and y is equal to 1. Once I've solved for one of the variables, I now have to decide where I'm going to plug into. In this problem here, I'm going to plug into, we'll say, the top equation. So remember that top equation was x plus 3y equals 5. Well, here's where I can take this y value of 1 and plug it in here for y, where y is going to be 1. As I do this, I get x plus 3 times 1 equals 5. X plus 3 equals 5. Subtract 3, x is equal to 2. And that helps to tell me that my solution has an x value of 2 when the y value is 1. How do we know if these solutions work? What we do is we plug in and test. If you would like to test, you would test into both the top equation and the bottom equation to verify this. I will show a check in the last one. I won't show the check here in the first or the second one. Let's take a look at problem number 3. In problem number 3, I need to locate one variable that can easily be written as x equals or y equals. Well, I believe that the easy equation to write as x equals or y equals is this y here. And that's because it has a negative 1 as its coefficient. In order to rewrite as y equals, we're going to have to do a little bit of algebra. So I'm going to add 5x over to the right side after adding it to the left side. And I get negative 1 times y is equal to 5x plus 12. I'm going to divide by negative 1. What I do to the left, I do to the right, and every term on the left. And I get y equals negative 5x minus 12. So what I've done here is I took the bottom equation and I've written the equivalent equation. I have just now reorganized it so now that it says y equals. What this allows me to do is to then substitute in. So again, I'm going to make a note here, and I'm going to substitute into the top equation. Well, where am I going to substitute into the top equation? I'm going to substitute in the top equation for y, right? What I'm going to be doing here is telling you that this is where my y previously was, but now I don't want to call it y. I can call it negative 5x minus 12 because y is equal to that value. That's the idea of equals here. So I get 3x minus 5 times parentheses negative 5x minus 12 equals 4. I do need to be careful here that I am subtracting a 5 times parentheses. So when I distribute here, I'm going to have to distribute a negative 5. As I do this, I am going to get 3x plus 25x plus 60 is equal to 4. I'm going to add like terms. 3x and 25x is 28x plus 60 is equal to 4. Subtract 60. 28x is equal to negative 56. Divide by 28. X is equal to negative 2. Squeezed it in there just at the bottom. I'm going to show an arrow. I'm going to come up to the top. Once I know what x is, how do we find what y is? We plug into one of the equations. I'm going to plug into, in this problem, the top equation. So what I'm going to do here is let x equal negative 2. And I'm going to get 3 times negative 2 minus 5y equals 4. Negative 6 minus 5y is equal to 4. Add over 6. Negative 5y is equal to 10. Divide by negative 5, and I will get y is equal to negative 2. That tells me here that my solution is negative 2, comma negative 2. Well, there are answer keys sometimes that we can check our work on, but how would you verify that you did this problem correctly? I'm going to call this checking your solution. So how do you check your solution? Well, what I'm going to do is I'm going to take and plug in negative 2 for x, negative 2 in for y, into not only the first equation, but also the second. So let's do it with the first one. I'm going to get 3 times negative 2 minus 5 times negative 2. And we want to know, does that equal 4? Does negative 6 plus 10 equal 4? And we just verified it works in the top equation. 4 does in fact equal 4. That makes that true statement. Let's take a look, though, at the second equation. I get negative 5 times negative 2 minus negative 2 equals 12. I like checking this one because as we check this, there's a lot of negatives in here that we have to be careful of. Here is a double negative. Subtracting negative 2, remember 2 negatives is going to make a positive. And if I take a look at this problem here, we get 10 plus 2 and we want to know, does that equal 12? Does 12 in fact equal 12? And again, that checks in the second equation. So we do in fact know that negative 2 comma negative 2 is the solution to that system. We are going to move on now here and take a look at day number 3, where we start getting into some word problems. We have laid out some steps for you to consider looking at application problems. Step 1 is we define our variables. What in fact is that we're trying to find? Step 2 is we're going to write a system of linear equations. That means that we're going to be writing 2 or more equations. For what we're doing today, we'll be writing 2 equations. We are then going to solve the system algebraically. When we say solving algebraically, we're going to solve it using substitution, or in the future we'll be talking about other methods. And then we want to explain our answer using complete sentences. So what that's going to do is bring some relevance to the scenario at hand. So let's take a look here at the first problem. And that first problem says you are going to go to the store, you're going to buy 8 pencils for $8 at the bookstore. Regular pencils cost 85 cents and specialty pencils cost $1.25. How many of each type of pencil did you buy? Well, this last sentence here is going to allow us to define our variables. It's asking you how many of each type of pencil did you buy. So I'm going to define my variables as number of, these are regular pencils. So this is talking about like a number 2 Ticonderoga. I also know that we have the other type of pencils is what they call the specialty pencils. What's a specialty pencil? They're talking about like a happy birthday pencil, a Pi Day pencil, you know, a Valentine's Day pencil, maybe a pencil that says boo on there for Halloween. But that's kind of the idea here of a specialty pencil is going to have some type of, graphic or design on it. Let's set up now our system. Well, if I'd like to set up my system, I need to come back to the top and see what I know. And when I go through what I know that I bought 8 pencils, right? So how do we figure out what the inequality is the equation that we use to write a total of 8 pencils? Well, let's think about it. If I bought 2 regular pencils, I would have to buy 6 specialty pencils, so we know that 2 plus 6 is equal to 8. Or in this case, if I buy X regular pencils, I'd have to buy Y specialty pencils to get a total of 8. I also now want to come back and I want to look at this other total. It tells me that I spent a total of $8. Well, what else is talking about money in this problem? Well, it's talking about regular pencils are 85 cents each, and specialty pencils are $1.25 each. So what I'm going to be able to do here is I can say that for every regular pencil, it costs 85 cents. For every specialty pencil, that's going to be $1.25. So this is going to give me the money plus the money, which is going to give me a total expense of $8. From here, once we have our system, we now get to work through solving it. I'm going to slide to prepare us to solve it, and we're going to solve this here using substitution. So how do we solve this using substitution? We look for one equation that can easily be written as x equals or y equals. Well, I'm going to go with the top equation. So the top equation was x plus y equals 8. If I subtract over y, I get x is equal to 8 minus y. Remember, we are going to take what x is equal to, and I'm going to plug that into the bottom equation for x. So as I get ready to do this substitution, I'm going to slide up here to allow me a little bit of space to write, but I get 0.85 is being multiplied by 8 minus y plus 125y, and that's equal to 8. Again, how did I get this? I was plugging into this top equation, or original equation, and substituting in right here for x. As I substitute that in there, I'm going to distribute 0.85 times 8, which is going to give me 68, or 6.8, minus 0.85 times y, plus 125 times y, equals 8. I'm going to combine some like terms here. When I combine my like terms there, I'm going to get 6.8 plus. As you add those up, that's going to be 0.4 times y is equal to 8. I'm going to subtract 6.8. 0.4y is equal to, that is going to be 1.2. And divide by 0.4, and y is equal to 3. Once I have what y is equal to, we now need to find x. Well, how do we find x? We plug into the ease of the two equations, which I would argue is the top equation. And if I plug into the top equation, I get x plus y, so x plus 3, because y we just found to be 3, is equal to 8 when x is equal to, that'd be 5, right? So what is our solution here? Our solution is 5, 3. Well, this 5, 3 is a fine-looking ordered pair, But what does 5, 3 mean with respect to the original problem? Well, how do we determine what 5 and 3 represent? We need to come back up here to the top and look at how we define these variables. So if I look at how we define those variables and we want to write this using a sentence, we can say you bought 5, come back up here to the top and look and say that would be regular pencils, and 3 specialty pencils. And that would be the explanation of what 5, 3 represents in this problem. Notice that we put it in a sentence using proper English and including units and bringing relevance to this situation that we are dealing with. Good luck with your homework, and that is a wrap for the notes.